Here we look at a new physics concept, that of pressure. Now pressure, represented by a capital P in your textbook, is the force applied to an object divided by the area that force is applied. So the pressure is force over area. Now this is very important because it means that to get a high pressure on something, you can have a large force over a larger area, or a small force over a smaller area will give you the same amount of pressure. Pressure has units of pascals. Now Pascal is represented by a capital P and a lowercase a for unit. Now this is the first time I believe we've come across a unit where you actually have two letters in that unit. Newton is a capital N, gram is lowercase g. You have a joule is a capital J. Now you might want to think, well, kilogram is a kg. Well, that K is a prefix. That means kilo, right? So you can have kilopascals, which would be a small k and a big P and a small a. So Pascal is the SI unit for pressure. So a millipascal will be a small m in front of that, or small k for kilopascal. Nanopascal will be a small n, and so on. 1 Pascal is 1 Newton over a meter squared. So pressure is an important concept, especially when talking about fluids, because it, we will see, is incredibly important when talking about how pressure changes within a fluid and how pressure affects a fluid. Other non-SI units of pressure, pascals you're probably not familiar with, but other units of pressure include, you might have heard of bars or millibars. You probably all have heard of PSI. I mean, if you own a car or a bicycle, you have to pump up your tires to a certain PSI. You know, road bikes, 100 PSI. For your automobiles, 30 PSI typically. Depending on the truck tires, semi-tires can be 100 PSI or more. You might have heard inches of mercury. If you have one of those old school weather stations in your house, where you have a barometer, which measures pressure, a temperature gauge, and a humidity gauge, you'll notice that the barometer is typically labeled in inches of mercury, where 30 inches of mercury is pretty average. It go down to 28 inches of mercury or up to 32 inches of mercury. And that allows you to measure whether or not you're in a low pressure or high pressure system for weather. And then likewise, you also have millimeters of mercury, which is used more commonly in countries that use the SI system. So pressure is an interesting physics concept. One example of how pressure can change. Imagine the shoes that you're wearing. Most people wear flats, right? So the force, your weight, over the area of your feet is the pressure that you put on the floor. You can increase that pressure. Well, you can't necessarily increase your own weight, but you can change the amount of area where you're applying your weight. Now, back in when airplane travel was first started, airplanes had to be made as light and as durable as possible in order to take off easily. So typically they're made out of aluminum. Now aluminum can actually be a very thin metal, and they had problems in the early flights where women wearing high-heeled shoes, very high stiletto-heeled shoes, when they walked on the plane surface, right, when they went to their seat, was that their weight was putting so much pressure on the floor that their heels would actually punch through the cabin floor, the passenger deck floor. So pressure is, again, how much force applied over what area.